Today we're going to talk about Umask and what Umask used for. In Linux, when you first create a file directory, the initial permission given will be 666 for files, which is read-write for user, read-write for group, and read-write for others. If you create a new directory, the initial permission will be 777, which is read-write execute, read-write execute, read-write execute for user, group, and others. As you can see, this can pose a security problem. That is to say, any user can read and write your files. Any user can read, write, and access your directories. They can even remove them if they want to. To change this behavior, we can use Umask to change the initial file permission. Example, if we do Umask equal to 002, then the initial file permission instead of 666 will become 664, and the initial directory permission will become 775. So as you can see, the resultant permission will be more secure than the initial file permission without Umask. How do we get 664? Is by taking the initial file permission, which is 666 minus 002, the Umask. Now note that this is not a decimal or a digit subtraction, but this is by octal value subtraction. What do I mean by that? You take 6, which is the user permission, minus 0 will give you 6. You take 6 of the group permission minus the 0, which will give you 6. If you take 6 of others permission minus away the Umask 2, you get 4, and this will result in 664. Same for directory, just take the octal value 777 and minus each individual Umask, which is 002. Note that there's no negative subtraction. If there's come across that you must take a smaller digit minus a bigger digit, then the negative result will be 0. Now, for example, if you are given the first initial file permission of 644 and directory creation is 755, can you derive the Umask given this initial file creation and directory creation permission? In this case, how do we derive the Umask? Is by taking the initial file permission, which is 666 minus 644, and this will be the resultant Umask of 022 for both file and directories. Let's take a look at example. We can use the Umask command, and for example, we do 000. That means that we do not want Umask to be set. You can type Umask to see the current Umask, which is set to 000. And let's see what happens if you touch a file. I'll create a new file called file.txt. Now here you can see I created a new file called file.txt, and if you list the permission of this file, you notice that the initial permission is 666, which is rw-rw-rw, given the Umask is not set. What happens if we create a new directory called some directory, and if you list down the permission of the directory, some directory, and you notice that the initial permission given to the some directory is 777. Now let's try changing the Umask. So we can change the Umask now to 002. What happened here is, let's say you create another file called file1.txt. Your resultant permission is no more 666 but rather 664. And if we create a directory for some directory 1. Your resultant directory permission is no more 777, but rather 775, which is a more secure way. If you like, you can check out this etc bash rc file, where you can set the global Umask. As you can see from this file, any UID or user ID that has UID greater than 99 will have Umask 002, and anything less than that will be 022. For example, I'm root, I have UID 0, which is less than 99. Thus, my Umask will be set to default 022. If I assume another user, say for example guest 1, and guest 1 UID is greater than 99, which is 503, my resultant Umask, or the default Umask set for me by the system, will be 002. This is what this means. If the UID is greater than 99, it will be set to 002. If the UID is less than 99, the Umask will default set to 022. This will be the end of the demo.